You step outside tonight and something is missing. The sky looks wrong. You glance up out of habit, the way you always do, and there is nothing there. No glowing circle. No silver light. Just black, empty space where the moon used to be. At first, you think it is clouds. You wait. Nothing changes. Your phone buzzes. Then it buzzes again. Within minutes, the buzzing does not stop. The moon is gone. Not behind the Earth. Not hidden. Gone. Astronomers around the world saw it happen in real time. No explosion, no flash, no warning. One moment it was there, tracked by telescopes and satellites, the same moon that has hung over every sunset and birthday and quiet drive home for your entire life. The next moment, sensors at NASA and the European Space Agency simply stopped detecting it. Scientists have a name for this kind of impossible, instant vanishing. They call it a thought experiment, because in real physics, nothing simply disappears. But let's imagine it did. What would actually happen to you? First, your body. You won't feel anything change in your skin or your bones, but your inner clock will. Humans evolved under a sky with a moon for over 4 billion years. Researchers studying circadian rhythms, including work supported by institutions like the National Institutes of Health, have found that moonlight subtly affects human sleep cycles, shifting how deeply and how long we rest during certain lunar phases. Without the moon, that quiet rhythm disappears. Nights become darker. Truly dark. The kind of darkness your great-great-grandparents barely experienced, let alone you. Think about what that darkness actually means for your daily life. Streetlights still work. Cities still glow. But step outside the city, into farmland or open countryside, and you would notice it almost immediately. No soft silver light to walk by. No shadows cast on a clear night. Camping trips, night hikes, even late drives down unlit country roads, all of it changes when the only light left in the sky comes from stars too faint to guide you. Search and rescue teams who work at night would lose a tool they have relied on for as long as humans have wandered after dark. Now think about the ocean. Have you ever stood at the edge of the sea and watched the tide pull back, exposing wet sand that was underwater an hour before? That motion is not random. It is the moon, pulling on Earth's oceans with its gravity, like an invisible hand tugging the water toward it. Sir Isaac Newton was the first to mathematically describe this gravitational relationship centuries ago. Remove the moon and that hand disappears. Within hours, tides begin to flatten. The dramatic rise and fall you grew up watching shrinks to barely a ripple. The sun still pulls on the oceans a little, but only about half as strongly as the moon did. Coastal ecosystems that depend on tidal rhythms, crabs, oysters, mangroves, entire food chains, begin to lose their timing immediately. Within days, fisheries report chaos. Within weeks, scientists at oceanographic institutes are tracking dying coastal habitats on every continent. Consider the people whose entire livelihood depends on knowing exactly when the water will rise and fall. Fishing crews who time their departures by tide tables. Shipping ports that schedule massive cargo vessels around predictable tidal windows, because many channels are only deep enough to pass through at high tide. Suddenly, those tables mean nothing. Harbors that relied on twice daily flushing to clear pollution and sediment stop flushing properly, and within months, some ports report water quality dropping sharply. Entire coastal economies built across centuries around a rhythm older than civilization itself would need to be rebuilt from scratch. But the bigger danger is not in the water. It is in the sky and underneath your feet. The moon does something most people never think about. It stabilizes Earth's tilt. Right now, our planet leans at about 23.5 degrees, and that tilt barely wobbles thanks to the moon's gravity holding it steady like a hand on a spinning top. This is why we have predictable seasons. This is why a calendar means anything at all. Take the moon away, and the wobble begins. Not instantly, not within the first day, but within decades. Computer models built by planetary scientists, including research published by French astronomer Jacques Lascar in the 1990s, suggest Earth's tilt could swing wildly, sometimes by tens of degrees over thousands of years. Imagine winters disappearing for a generation, then returning twice as brutal. Imagine deserts turning to ice, and ice turning to desert, not over millions of years, but within a human lifetime. What would you actually see during this shift? Picture a summer where the sun never sets, followed by a winter decades later where it barely rises. Picture migratory birds, the ones that time their flights by daylight and temperature, arriving at the wrong continent at the wrong season, over and over, until their populations collapse. Now picture your own grandchildren, generations from now, living through a version of Earth your calendar was never built for. Farmers who plant by season would find the seasons themselves unreliable. A spring planting could be followed by a frost that should never happen in that month, then by a heat wave that belongs to a different climate altogether. Entire regions that depend on predictable rainy seasons, like parts of South Asia that rely on monsoon timing, could see those patterns thrown into disarray, threatening food supplies for hundreds of millions of people. Climate scientists, the kind who contribute to reports from organizations like the IPCC, would spend decades simply trying to understand the new normal, because the old models were all built on an Earth with a stable tilt. And what about tonight, the very first night? Without the moon, the night sky turns pitch black between stars. No more moonlit walks. No more silver light reflecting off rivers and lakes. Predators that hunt by night, owls, big cats, and countless insects that navigate by moonlight suddenly lose their primary tool for survival. Some moths, scientists have shown in studies on insect navigation, literally use the moon as a fixed point to fly in a straight line. Remove it, and they spiral in circles until exhaustion. Sea turtles face their own crisis. Hatchlings instinctively crawl toward the brightest light on the horizon after breaking out of their shells, normally moonlight reflecting off the ocean. Without that beacon, researchers who study nesting beaches warn that hatchlings could become disoriented, crawling inland toward artificial lights instead of out to sea, a problem already documented in areas with heavy beachfront lighting. Multiply that confusion across every moonlit-dependent species on Earth: coral that spawns in sync with lunar cycles, wolves whose hunting patterns shift with moon phases, and you start to see how deeply this single object is woven into life on this planet, far beyond just human eyes looking up. Here's something you might not expect. Earth's rotation itself would change. The moon currently acts like a brake, slowly slowing our planet's spin over millions of years. That's actually why days are gradually getting longer, a phenomenon confirmed through tidal friction studies. Without the moon's gravitational drag, Earth's rotation would not continue slowing the same way. Over an extremely long timescale, your 24-hour day could shift year after year in ways human civilization has never had to adapt to. There's a darker possibility, too. Some researchers, building on the work of astronomers studying our solar system's formation, point out that the moon may have helped shield Earth from some impacts over billions of years, absorbing debris that might otherwise have struck us directly. Look at the moon's surface sometime, covered in craters, a visible record of impacts it has taken instead of us. Remove that shield, and over the very long run, the odds of Earth taking a direct hit increase, even if only slightly. So how would humanity respond? Not with panic forever. Humans adapt. Within the first year, calendars based on lunar cycles, used by billions of people for religious and cultural observances, would need to be redefined. Coastal cities would begin re-engineering infrastructure built around predictable tides. Within a decade, agriculture in regions affected by shifting seasonal patterns would need new crop strategies. Scientists, the kind in white coats hunched over data at places like NASA's Jet Propulsion Laboratory, would spend careers studying a planet behaving in ways it never had before. Governments would face decisions no government has ever had to make. How do you plan a national budget around unpredictable harvests? How do you insure coastal property when tides no longer follow the patterns insurers have tracked for a century? Engineers would propose wild ideas. Artificial satellites large enough to mimic some of the moon's gravitational pull, though most physicists would point out that nothing humans could build comes close to matching a body that took up roughly 1/80th of Earth's mass for billions of years. Slowly, painfully, a new kind of normal would form, one built on adaptation rather than the steady certainty your ancestors always took for granted. And here is the twist. For all the danger, something would also be lost that has nothing to do with science. Think about every love song written under a full moon, Every culture's myths, from the man in the moon to lunar New Year celebrations to ancient calendars carved into stone, built around that same silver circle in the sky. Poets, sailors, farmers, and lovers have used the moon as a clock, a compass, and a companion for as long as humans have looked up. Carl Sagan once spoke about how a single object in our sky shaped human imagination across every civilization that ever existed. Without it, something quietly human would vanish too. Not just tides and seasons, but a piece of shared wonder that connected every person who ever looked up at night. So tonight, when you step outside and the moon is exactly where it should be, hanging steady and familiar above your street, take a moment. It is not just a rock in the sky. It is the reason your tides are predictable, your seasons are stable, your nights are never fully black, and your calendar makes sense. It has quietly held your world together for over 4 billion years, asking for nothing in return except a glance upward every once in a while. You check your phone and discover the moon has vanished. Now flip that thought. Tonight, you step outside, you look up, and there it is. Steady, glowing, and still holding your entire world in place.